Hi guys, today I'd like to discuss our project, which is melanoma detection using a custom unit model. I'd like to start by giving you an introduction. Melanoma is a lethal form of skin cancer that develops in our melanocytes in the skin when they are exposed to high levels of UV radiation. The unit architecture is a powerful deep learning technique which was developed specifically to work on biomedical segmentation and classification problems. In this project, we would be developing a unit model from the unit architecture from the ground up, which includes encoding and decoding aspects of it. This is a high level overview of what we are going to be doing in the project. The first steps would be, of course, to develop a unit model. And then if time permits, we are also planning to develop an autoencoder. The data set is called the HAM 10,000 data set, which was developed by Harvard. It has about 10,000 images of skin lesions. Our problem that we are trying to address is a supervised machine learning problem, which has a classification associated with it. So it is supervised because the data set is already labeled by subject matter experts. And it is a classification problem because we are trying to say definitely whether the input image has melanoma or not. This is the process diagram that we have developed for our project. So the data is going to be split into 60, 20, 20, which is training, testing, and validation. Then we are going to proceed with the pre-processing steps and then developing the model, which has two phases. Each phase has about 4 steps. Then we'll proceed into training and validating the data. And then finally, we'll move on to testing. Testing, we are planning to implement a couple of loss functions. One is binary cross entropy, and the second is weighted cross entropy. So both of these are sigmoid functions, which are used extensively to benchmark classification problems. This is a generic example of what a unit model usually looks like. So it is a symmetric architecture, basically where we are doing encoding on the left side and doing max pooling to compress the image. And then as we move up, we are trying to decode the encoded image back into the original form. Moving on to the activation functions, we are planning to use ReLU in our layers and sigmoid in our, softmax in our final layer for activation. And concluding thoughts, I would like to say that we are trying to benchmark our models against existing models like SVM, CNNs, and other ensemble learning models. I say that our project will be significant because detecting skin cancer early can increase the chance of survivability by a large margin. So I hope our project interests you and also has a significant impact on the medical community. Thank you for listening to this and have a great day.